Question number 6. A particle moves along a straight line, and you guys can see that this is a graph of the velocity, between 0 and p. So it starts at 0, it has all these points, and then it ends over here at p. It tells us that j, k, l, m, n, and r constants. The graph intersects the horizontal axis at t equals 0, k, m, and p. So it intersects the horizontal axis here, 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 and here. And it has horizontal tangents at j, l, and n. So there's a horizontal tangent here, here, and here. For what values of t is the speed of the particle increasing? So, a couple things we need to remember. Remember that the original function f is like s of t, the position. The first derivative, s prime of t, is equal to the velocity. And the second derivative, s double prime of t, is equal to the acceleration. So, this graph that we're looking at is the velocity function, which means it's like the first derivative. So this is like the first derivative of a function. It says, for what values of t is the speed of the particle increasing? So remember that in order for the speed to be increasing, the velocity and acceleration both need to be the same sign. So they both either need to be positive or both either need to be negative. So looking at our graph over here, if this is velocity, remember that velocity is positive when it's above the x-axis, and velocity is negative when it's below the x-axis. So I can visually see when it's positive and when it's negative. The one I need to worry about is acceleration, making sure that it's the same sign when it needs to be. And remember that acceleration is positive whenever the velocity function is increasing. So for example, acceleration is positive here, and it's positive right here. Acceleration is negative whenever the velocity function is decreasing. So for example, right here, and over here. So, in order to figure out where they're the same sign, they either both need to be negative or both need to be positive. So, these values here are negative because they're below the x-axis, and they're decreasing, which means that acceleration is negative. So these values fit the description, where speed will be increasing because it's increasing in the negative direction because both the acceleration and velocity are both negative. Right here, velocity is negative, but acceleration is positive, so that's a no-go. Right here, both of them are negative again, so we like these values. Because velocity and acceleration are both negative. Right here, velocity is negative, but acceleration is positive, so that's a no-go. Right here, acceleration is positive because it's increasing, and velocity is positive because it bumped above the x-axis, so we like those values because they're both the same sign there. And then over here, we don't like it again because even though the velocity is positive, the acceleration is negative since the function is decreasing. So the answer would be from 0 to j, k to l, and m to n. And the answer to that is D, 0 to j, k to l, m to n.